Today's topic is single electron transistor. We simply call it as SET. S-E-T. S stands for single, E stands for electron, T stands for transistor. Single electron transistor. So before we go into this topic in depth, so we have some introduction about some phenomenon. After that we will move to the single electron transistor. So here we have some important phenomena like tunneling. So one of the important phenomena which is related to the single electron transistor is tunneling. Let's see what is the meaning of tunneling. See, suppose we all know that electron is a particle, right? So when the electron encounters a energy barrier in an electronic structure, the electron is suddenly penetrates through the structure. That means barrier. So this is called what? Tunneling. Okay. So here we have another terminology, electron tunneling. So as I mentioned earlier, tunneling means, so when the particle like electron, when suddenly face or suddenly experience a energy barrier in a electronic structure, the electron is suddenly penetrate through the structure. So this is called what? Tunneling. Let's see the meaning of electron tunneling. So in the electron tunneling, there are two phenomena is involved. So first one is classical view. The electron tunneling can be understandable through the two phenomena called classical, under the classical view and quantum view. So let's see what's the meaning of classical, let's see the meaning of classical view. So here for this we can consider a energy barrier in a electronic structure. So the barrier is like a wall. The barrier is like a wall. So consider an electron. So you just imagine there is an energy barrier of electronic structure. There is an electron. So when the electron move towards the wall, move towards the energy barrier, it is suddenly bounced off and reflected back, returned back. So what's the reason behind the concept? So here the electron exhibits its particle nature. Particle nature, that's why the electron behave like a particle, like a ball. So when it is hit the electronic, energy barrier in the electronic structure. So as I mentioned earlier, this is like a wall, right? Whenever there is a ball, you just imagine there is a ball, whenever it hit the wall, it will be bounced off. Like that, here the electron, when it is hits on the energy barrier, it will be immediately bounced off like a ball from a wall. So let's see what's the phenomenon behind this. See here, according to the classical view, the electron exhibits its particle nature. Since it is act like a particle, right? Whenever it hit the energy barrier, it will be immediately reflected back. That is a reason the electron cannot penetrate through the energy barrier. So this is what energy barrier in the electronic structure. So that what we can conclude, the electron cannot penetrate through the energy barrier because here electron exhibits its particle nature. Let's see the quantum view. So here also we can consider a energy barrier as we consider in the earlier case. So there is an energy barrier in the electronic structure. And according to the quantum view, electron exhibits its wave nature. In the case of classical view, electron exhibits its particle nature so that it cannot penetrate through the energy barrier. Whenever the electron faces the energy barrier, so it cannot penetrate through it. So instead of that, it will be reflected back like a ball from a wall, according to the classical view. But according to the quantum view, electron behave as a wave. So here it is called electron wave. So let's see the difference between the classical view and the quantum view. So in the case of classical view, electron exhibits its particle nature as we discussed earlier. But according to the quantum view, electron exhibits its wave nature. Since electron exhibits its wave nature, whenever it experiences a energy barrier, electron can be able to penetrate through the energy barrier and it can able to come out of the other side of the energy barrier, unlike the earlier case. The reason behind this, in the earlier case, the electron exhibits its particle nature, but here the electron exhibits its wave nature. Since it exhibits its wave nature, it can be able to penetrate through the energy barrier. Okay. Right. That's why the electron tunneling is possible under the quantum view. It is not possible under the classical view. Let me discuss about the single electron phenomena. So in order to understand the single electron transistor, there are so many terminologies are there like tunneling, electron tunneling, right? We have one more important phenomena called single electron phenomena, right? So actually, if you are, we all know that electronics is a very big domain in which transistor play a very important role. So in the case of electronics, transistor play a very important role because transistor uses a small switches for on and off operations Also it is used for transferring and amplifying the signals, right? So in the year of, in 1970s, in silicon transistor requires about 10 million electrons, 10 million electrons for its operation, 10 million electrons for its operation. Very recently, we are in the need of 10,000 electrons, 10,000 electrons for operating a transistor. But very recently, in the nowadays, we are in the need of single electron or single atom that is sufficient to operate a transistor. So that's why it is called a single electron transistor. So to achieve the single electron phenomena, there are two things to be maintained. One is Coulomb-Blackett effect. Coulomb-Blackett effect. Second one is overcoming uncertainty. See, in order to achieve the single electron phenomena, we need to satisfy the two effects. One is called Coulomb-Blackett effect and other one is overcoming the uncertainty. Let's see the meaning of Coulomb-Blackett effect and the overcoming uncertainty little later. So to understand the single electron transistor in the view of construction and working, first we should understand the, let's compare the single electron transistor with the field effect transistor. So let's see the difference between the field effect transistor and the single electron transistor. After that we will move to the next talk. So here I am giving the structure of the field effect transistor for your understanding. Also I am going to compare with the set. Field effect transistor going to compare with the set for your understanding. So here we have a source. So the FET is a 3-terminal device. So one terminal is source. It can be simply denoted by S. And second terminal is drain. Simply denoted by D. And we have one more terminal called gate. Simply call it as G. So this is what construction of the FET, that is field effect transistor, field effect transistor. Simply call it as FET. So let me compare the FET with the SET. In the case of SET, we have a quantum dot. So quantum dot, then we have a source, then we have a drain, then we have a gate. So similar to the FET, this is also 3-terminal device, as I mentioned earlier. So one of the terminal is source, another terminal is drain, and third terminal is gate. So this is what quantum dot, Q dot, quantum dot, also call it as island. So this one is source, and this one is gate, and the third one is drain. So in between the source and the quantum dot, and in between the drain and quantum dot, we have some gap. So this is called tunnel junctions. Tunnel junctions. And between the gate and quantum dot, we have a gate capacitor. So this is what SET, single electron transistor. So in order to understand the SET clearly, we need to compare the SET with the FET. So to understand the construction and working of single electron transistor, it is necessary to compare the single electron transistor with the field effect transistor. So in the field effect transistor, we have a 3-terminal. We have 3-terminal. As I mentioned earlier, one is source, second one is drain, third one is gate. So we have a semiconductor channel in the FET. And come to the single electron transistor. Here we have a block diagram of single electron transistor. Here we have a quantum dot. So the central part of the diagram is nothing but quantum dot, Q dot, also call it as island. So the quantum dot is placed between the source and the drain. So in between the quantum dot and the source, we have a insulating material, thin insulating material. So it is called tunnel junction. It is called tunnel junction. So in between the quantum dot and drain also we have one more small thin insulating material between the drain and quantum dot. So it is also called it as tunnel junction. So collectively we have two tunnel junctions. We have it between the source and the quantum dot and the drain. So we have one more thing, that is one more terminal. It's nothing but gate. So in between the gate and the quantum dot, we have a gate capacitor. So when we compare these two diagrams, right, we can able to understand that in the case of single electron transistor, we have a quantum dot instead of semiconductor channel. Actually, in the case of field effect transistor, we have a semiconductor channel. Instead of semiconductor channel, we have a quantum dot. So this is the only difference between the FET and SET. So this is what off mode. Here the gate voltage equal to 0. That means it is not operated. Actually it is in the off state. So the electron which are in the source still in that place only. It will not move from source. It will be there only. As we discussed earlier, the source having electrons. In between the source and quantum dot, we have a Coulomb blockade. Coulomb blockade is nothing but a thin insulating material which is placed between the source and quantum dot and between the quantum dot and the drain. So the purpose of the Coulomb blockade is prevention of the or suppression of the or preventing the movement of electron from source to quantum dot. So here in this situation, so this is what energy level diagram. So when we look at the energy level diagram, the energy level of the quantum dot is equal to energy level of the source. So this is not energetically favorable to the movement of electron from source to quantum dot. So that no electrons will move from source to quantum dot. All the electron will be there in the source. This is what off mode. Let's see the on mode. So in the case of on mode, here the gate voltage is gate voltage equal to Coulomb voltage. In the case of off mode, that time the gate voltage equal to 0, Vg equal to 0. That's why no electrons move from source to drain via the quantum dot. Electrons only there in the source in the case of off mode. Now we are going to see the on mode. So in the case of on mode, now the single electron transistor is in on state, so that the electrons will move from source to drain via quantum dot, one by one. So let's see the corresponding energy level, potential energy level of the single electron transistor. So similar to the previous case, here we have the source, quantum dot, drain. So in between the source and the quantum dot, we have a Coulomb blockade, and similarly in between the quantum dot and drain, we have a Coulomb blockade. So only one difference between the previous case and this case. So the difference is, as we look at the earlier case, the energy level of the quantum dot is equal to energy level of the source in the previous case. It is not energetically favorable to movement of the electron from source to quantum dot. But in the case of on mode, what will happen? The potential energy of the quantum dot is little lowered compared than previous case. So this situation is energetically favorable to the movement of electrons from source to quantum dot. So here we can look at the energy level of the quantum dot and energy level of the source. So here the energy level of the source is higher than energy level of the quantum dot. So it is energetically favorable for the movement of electron from source to quantum dot. So that in this situation, one electron going to tunnel through the Coulomb blockade. How it is possible? As we discussed earlier, here the electrons exhibit its wave nature. So electron behave like a wave according to the quantum view. According to the quantum mechanical view, the electrons exhibit its wave nature, right? That's why the electrons going to penetrate through the Coulomb blockade. Coulomb blockade is nothing but thin insulating material which prevent the flow of electrons from source to quantum dot. Okay. So in the case of classical view, as we discussed earlier, in the case of classical view, let us consider a energy barrier in an electronic structure. So when the electron move towards the energy barrier, the electron, when the electron hit the energy barrier, it will be reflected back, bounce off from the energy barrier, similar to the when the ball is hitting the wall, it will be immediately bounce off. Like that, here when the electron is hit the energy barrier, it will be reflected back because the electron exhibits its particle nature according to the classical view. But in the case of quantum view, the electron exhibits its wave nature. As we discussed earlier, electron exhibits its wave nature. Since it exhibits its wave nature, the electron can able to tunnel through the energy barrier and able to come out of the other side of the junction. So here the energy barrier is nothing but the Coulomb blockade, which prevent the flow of electrons from source to quantum dot. When the electron exhibits its particle nature, that time it is not possible. The electron cannot tunnel through the energy barrier because it exhibits its particle nature. But according to the quantum view, when the electron exhibits its wave nature, so that it can able to tunnel through the barrier, as you can see in the picture, able to come out of the other side of the junction. The same phenomena will happen in the energy level diagram. So the electron from the source tunnel through the Coulomb blockade because electron exhibits its wave nature, right? So that it can able to penetrate through the Coulomb blockade and reach it to quantum dot, quantum dot. So this is what electron. So the electron now able to move from source to quantum dot through the Coulomb blockade. So once the electron reaches the quantum dot, the potential energy of the quantum dot increases. That means the energy level of the quantum dot, potential energy of the quantum dot increases. Once the dot reaches the quantum dot, energy level of the quantum dot rises up to energy level of the electron. So, as we discussed earlier, before the electron reached from source to quantum dot, that time the energy level of the quantum dot was little lowered compared than source. But once the electron reaches from source to quantum dot, the energy level of the quantum dot rises equal to energy level of the source. So as we discussed earlier, the electrons are available in the source, right? And as usual, here we have a quantum dot. And here we have a drain. Actually, the electrons will move from source to drain via the quantum dot. So in the off state, the Coulomb voltage is equal to 0. That's why electrons will not move from source. It will be there in the source itself. when the Coulomb voltage is equal to, when the gate voltage is equal to Coulomb voltage, right? So this situation will be favorable to the movement of the electrons, so that one electron will move from source to quantum dot, source to quantum dot, as we discussed earlier, right? So now the electron is moving from source to quantum dot as shown in the diagram. So this is what source, as we discussed earlier, electrons available in the source, and next to the source we have a Coulomb blockade, which is used to prevent the movement of the electrons. Then we have the quantum dot. Then we have one more Coulomb blockade. Finally, we have a drain. So as we discussed earlier, when the situation is favorable to the electron, it can able to move from source to quantum dot by tunneling through the Coulomb blockade, and it will reach the quantum dot, so that what will happen, the energy level of the quantum dot is rises up to energy level of the source, as we discussed earlier. Right. Now the electron move from source to quantum dot, right, as we can see in the previous case, right. Then once the electron reaches the quantum dot, the energy level of the quantum dot rises equal to energy level of the source. Finally, we have a drain. So as we discussed earlier, when the situation is favorable to the electron, it can able to move from source to quantum dot by tunneling through the Coulomb blockade, and it will reach the quantum dot, so that what will happen, the energy level of the quantum dot is rises up to energy level of the source, as we discussed earlier. Right. Now the electron move from source to quantum dot, right, as we can see in the previous case, right. Then once the electron reaches the quantum dot, the energy level of the quantum dot rises equal to energy level of the source. Right. Now the electron is going to move from quantum dot to drain, So in this situation, the energy level of the drain is lowered in order to accept the electron from quantum dot to drain, so that the electron will move from quantum dot to drain, tunneling through the Coulomb blockade. Now the electron reaches to drain as shown in the diagram. So once the electron reaches to the drain, the energy level of the drain increases. So this will repeated in so many times, so that the flow of current from source to drain through the quantum dot is controlled by quantum dot. So the quantum dot controls the flow of current one electron at a time. So this happens in the single electron transistor. So let me summarize the single electron transistor. So as we discussed earlier, the single electron transistor is nothing but a transistor which is used as a switching devices, small switching devices, and also is used for amplifying the signals, transferring and amplifying the signals. In general, the transistors are used for switching purpose, transferring the signals, amplifying the signals. We all know that. And as we discussed earlier, the single electron transistor means it's a very, very important transistor. To understand the single electron transistor, first we should understand the normal field effect transistor. So the field effect transistor can comparable with the single electron transistor, and so for the better understanding, let's start with let me recall the meaning of tunneling, then electron tunneling. So as we discussed earlier, tunneling is a phenomena in which the material particle like electrons, right, whenever it is face energy barrier in the electronic structure, it suddenly penetrates, tunneling. It's called tunneling. Then electron tunneling means so the electron tunneling can be understandable through the two concepts. One is classical view and other one is quantum view. So under the classical view, the electron exhibits its particle nature. So that it cannot penetrate through the energy barrier. So that whenever the electron face or hit the energy barrier, it will be reflected back like a ball bounced from a wall. So that according to the classical view, it is not possible. The electron cannot tunnel through the barrier. So whenever it hit the energy barrier, it will be reflected back is bounced from the energy barrier because it exhibits its particle nature. So under the quantum view, electron exhibits its wave nature. Since electron behave like a wave, it can able to penetrate through the barrier, so that electron tunnel through the barrier and able to come out of the other side of the barrier, since electron exhibit its wave nature. So this is called what? Electron tunneling. And let me recall the single electron phenomena. So as we discussed earlier, whenever we talk about the transistor, let's go for the 1970s. So whenever we want to operate a transistor in those days, in 1970s, minimum of 10 million electrons required to operate a single transistor, right? And recently means a few years back, we are in the need of 10,000 electrons to operate the transistor, right? And very recently, nowadays, even a single electron is sufficient to operate the transistor, or single electron or single atom is sufficient to operate the transistor. That's why it is called a single electron transistor. So single electron phenomena means a single electron sufficient or required to operate a transistor. And what is the usage of transistor? We already mentioned that the transistor is nothing but what? It's play a very important role in the electronics domain. It is used for the small switching devices, and in addition to that, the transistors used for transferring the signals, also amplifying the signals, right? So this is what usage of the or application of the transistors. And there are two rules to be satisfied to get the single electron phenomena. One is called Coulomb blockade. Other one is called overcoming the uncertainty. So let's see the meaning of Coulomb blockade. So Coulomb blockade is a phenomena or effect which is used to prevent the unwanted tunneling of the electron, or it is oppose the flow of electron from source to drain, source to quantum dot. So actually the Coulomb blockade, so the purpose of the Coulomb blockade is suppression or prevention of the movement of the electron from source to quantum dot. Because the Coulomb blockade is nothing but what? It's an insulating material which prevent the flow of electron from source to quantum dot. So this is what one rule to be satisfied in order to get the single electron phenomena. And the other rule is overcoming the uncertainty. So overcoming the uncertainty used to keep the quantum dots electronically isolated. As we discussed earlier, the quantum dot is also called it as island because it is surrounded by insulating material. That's why the quantum dot is electronically isolated because of the overcoming the uncertainty. So these are the two rules to be satisfied, two conditions to be satisfied to achieve the single electron phenomena. So what are the two rules are there? One is Coulomb blockade, which prevent the tunneling of electron from source to quantum dot, and other one is overcoming the uncertainty, so which is used to keep the quantum dot electronically isolated. So this is what single electron phenomena. And and we compare the single electron transistor with the FET, field effect transistor, for your understanding. So the single electron transistor, this is what block diagram of single electron transistor, right? Here it consists of quantum dot. It's made from quantum dot. The single electron transistor made from quantum dot, which controls the flow of current from source to drain by one atom by electron by electron. One electron at a time. One electron at a time, right? So the difference between the FET and SET is, in the case of field effect transistor, the field effect transistor also three terminal device. Like single electron transistor, the field effect transistor also three terminal device. It is consist of source, drain, gate, and in addition to that three terminal, it has semiconductor channel. So come to the single electron transistor. This is also three terminal device, as we discussed earlier. So one terminal is source, other terminal is what? Drain, and third terminal is what? Gate. So the difference between the SET and FET is, in the case, the semiconductor, in the case of field effect transistor, when the semiconductor channel is replaced by quantum dot, it is called SET. In the case of FET, we have the semiconductor channel. So when the semiconductor channel is replaced by quantum dot, then it is called single electron transistor. And here this is what schematic diagram of the SET. Schematic diagram of the SET, which consists of source, quantum dot, drain, and in addition to that it consists of a gate. And this diagram is called energy level diagram. Energy level diagram. So this, as I mentioned earlier, this diagram is called block diagram of SET. This is what schematic diagram of the SET, and this is what energy level diagram of the SET. So this diagram explains about the parts or construction of the terminals, three terminals like such as source, drain, quantum dot. Also it explains the gate. It shows the gate similar to the block diagram. So this diagram is specifically explain the energy level of the source, quantum dot, and drain. So the main purpose of the single electron transistor is what? The electrons are move from source to quantum dot and quantum dot to drain. So one electron. So each electron is accountable. Each electron is countable, considered. So one electron there are so many electrons are there in the source, but only one electron will move from source to quantum dot, from then quantum dot to drain. As I mentioned earlier or already explained earlier, so the electrons initially available in the source, right? Actually the destination, the electron's starting point is source and it will reach the destination point is drain. So in between the electron crosses the quantum dot. Via the electrons move from source to drain via the quantum dot. So in between the source and quantum dot we have a Coulomb blockade which prevent the flow of electrons. So at the initial stage in the off mode, the energy level of the quantum dot is equal to energy level of the source. So this is what not energetically favorable, so that electrons will not move from source to quantum dot. Then in the off state, in the on mode, what will happen? When the gate voltage equal to Coulomb voltage, this situation is electronically favorable to the quantum dot to receive the electron from source to quantum dot. So that the energy level of the quantum dot is little lowered compared than energy level of the source. So it is this situation is favorable to receive an electron from source to quantum dot. Then electron crosses or tunnel through the Coulomb blockade and it will reach the quantum dot. Then energy, once the quantum dot reaches, once the electron reaches to quantum dot, energy level of the quantum dot increases. It will increases up to energy level of the source. Then after that, the electron will move from quantum dot to drain. So what will happen? In order to receive the electron from quantum dot to drain, the energy level of the drain little lowered in order to receive the electron. Once the electron reaches to the drain, the energy level increases. And so in the exam point of view, initially we need to start from tunneling. We need to give the explanation about the tunneling, about 4 to 5 lines. After that, we need to explain the meaning of electron tunneling, under which give the 2 cases. One is classical view and other one is quantum view. After that, write few lines about the single electron phenomena. Then we need to write the principle, construction. In the construction, we need to write the schematic diagram. We need to draw the schematic diagram. Before that, initial stage, when we write the principle, after the principle, we need to draw the block diagram. Then you can give under the construction, you can give the schematic diagram. Under the working, you can give the energy level diagram. After that, write few applications, write few advantages, disadvantages. Thank you.